For this week's independent study video, we are going to be doing the introduction unit, so hopefully it's nice and straightforward. We've done several of these already, so I'm hoping you'll see that it's a little bit of a review. But in Chapter 8, we're going to be talking about quadratics, solving them, graphing them, which they would be parabolas. We'll get to that later in the week. But a quadratic is in the form ax squared plus bx plus c, and then we're going to be solving, so they're going to be equal to 0. There are several different methods to go about solving these, and the first couple should look pretty familiar to you. So in number 1, I have x squared plus 15x plus 44 equals 0. I'm going to solve, and this one is factorable. I can think of two numbers that multiply to 44 and add to 15. So 4 and 11. So I can factor it nicely. And I don't have to check. I don't have radicals. I don't have denominators. So we are good to go. The same thing with number 2. I just wanted to give you one where the leading coefficient was not a 1. So two numbers that multiply to negative 144, but add to negative 10. And I'm going to do my weird breaking math, but don't worry, we're going to fix it. So negative 18 and 8. So I'm going to put the 9x in the beginning of each parentheses, knowing that they're not going to stay there. So negative 18 and positive 8, and then I'm going to simplify each of those. And when I solve, I add 2, and then I'm going to subtract 8, and then divide by 9. And I don't have to check them. Obviously, you can if you want to make sure that you've got the right answer, but there's no extraneous solutions in these problems. So hopefully 1 and 2 are a review for you. Number 3 is going to look a little bit different. So you'll notice in 3 and 4, for that matter, there's just one x term right now in the equation. So that's telling me that I can use the square root property. And what the square root property says, move everything without an x to the other side, and then just take the square root of each side. So I'm going to subtract 4 and divide by 25 so I can isolate that x. Then the inverse of squaring something is to square root it. And we learned last chapter that the square root of a negative number is going to involve an I. So the square root of 4 is 2. The square root of 25 is 5. And then I have that I that I took out. Let me try to do that in another color for you. The only difference is that because it was my idea to introduce the square root, you're going to need a positive and a negative option. So you're going to have a positive or negative 2/5 I. You can also put the I up with the 2 if you would like. Same method for number 4. I'm going to add 48 to both sides. I'm going to get rid of that square by square rooting both sides. It was my idea to square root, so I'm going to do that plus or minus. And then I'm going to break down 48 into 16 and 3. I've noticed I've got a pair already, so I'm going to go ahead and take those out now. Then my job is to isolate the x, so I'm going to add 5. And I can't actually add or subtract 5, or excuse me, add 5 to the positive and negative 4 square roots of 3, because the 5 doesn't have that square root of 3 attached to it. So I'm just going to leave it. And then I'm going to divide by 3. So I'm still going to have 2 answers because it's a quadratic. So I know I'm going to have 2 answers, but I'm just going to leave it as the gross decimal and not even touch my calculator. So 3 and 4 are involving the square root property. Number 5 is not a quadratic, but is solved that way. I always go back to factoring as my first method, especially since there's 2 x components. So 2 numbers that multiply to 6 and add to negative 5. So I've got negative 3 and negative 2. The only difference with number 5 is I have to take that x to the 4th, and split it nicely between my two parentheses. Then when I take that and set each one equal to 0, remember I should get 4 answers because it's to the 4th power. So I'm going to add 3, square root, my idea to square root, so I need the positive and negative answers. And then same thing with x squared minus 2. So this is the only one so far that we've done that's to the 4th power. And there's my 4 answers to go with it. I will not ask you to graph that like I would the first 4, but we'll do those later on in the chapter. The last one is a little bit something different. I'm going to do it in another color to kind of draw your attention to it. This is called, still going to factor, but it's a method called U substitution. And you're going to use it quite a bit when you get into calculus in a couple years or next year for those of you that want to do the pre-calc over the summer. So in this, I noticed that I've repeated this x squared minus 4. So I'm going to let u equal x squared minus 4 because I do not want to square that component. I don't want to distribute the 2 and have to try to factor it that way. But if I replace all the confusing stuff with a u, all of a sudden my quadratic that I have is a lot easier to solve. So I can solve by factoring 2 numbers that multiply to -3 and add to 2. And my 2 potential answers for u are -3 and 1. Now, the question did not ask me to solve for u, it asked me to solve for x. That was my original variable. So all I'm going to do is take what I got for my u's and substitute them in for u to get my answers in terms of x. So -3 was my first answer. So I'm going to let -3 equal x squared minus 4. And then I'm going to solve. I'm going to add 4. And then my idea to square root means I'm going to have 2 answers. The square root of 1 is 1, 1 positive and 1 negative. And then I'm going to do the same thing for my 1. Plug it in for u and turn it into an x. So I'm going to add 4. I want to completely isolate that x, so I got to get rid of my square. My idea to get rid of that square, I'm not sure what I'm doing there. So I need the plus and minus. So my final answer is going to be the 1 and the -1 from the original u, and the square root of 5 and negative square root of 5 from my other u. We're going to do more practice with this u substitution, but I at least wanted to introduce it to you today. And this completes page 38 of your notebook. I highly recommend that you go through the practice problems that are with it and try to do a couple just to make sure you understand it as well as you think you do.